Today, on how it's made. Filigree glass. Fish food. And motorhomes. Filigree glass is a highly advanced form of glassmaking. The artists first produce threads of colored glass, then weave these threads together in intricate patterns, encasing them within clear crystal. Complex glassmaking techniques shape these patterned rods into breathtaking works of art. The filigree glass technique was invented in the 1500s by master glassmakers in Murano, Italy. Their then secret process incorporated ancient methods from Mesopotamia, the birthplace of glassmaking some 2,000 years earlier. It all begins with a blend of mostly silica sand, soda ash, and lime. They heat the mix to 1300 degrees Celsius, melting it over several hours into lead-free liquid crystal. With a steel rod called a punty, the glassmakers roll some molten crystal on a metal table as it cools and solidifies, a shaping technique known as marvering. Then they use the post they've shaped to pick up a piece of densely colored glass called a color bar. They melt the color on the end of the crystal post. At the same time, they heat another color bar into a molten state. Then they perform a process called overlaying. They push the molten colored glass over the other color bar, then marver until the colored glass symmetrically encases it. They encase the color in clear crystal and reheat some more. Then prepare a new bit of clear crystal on another punty. They use it to grab the free end of the color overlay. The glassmakers pull, stretching the crystal like taffy into what's known as overlaid cane, a thin rod of crystal with a thread of colored glass inside. It takes tremendous expertise to stretch the rapidly cooling glass to a consistent diameter without twisting or breaking it in the process. They snip the long cane into manageable lengths. Next, they cut the colored rods into the size required. Lay out the rods in a precise configuration, heat, then roll them onto a precisely sized piece of molten clear crystal. Now they repeat the pulling process, but this time, to create the internal pattern they want, they twist both punties. They use an electric drill to ensure steady, uniform revolutions. The rod this creates is called a complex cane. After it cools and stabilizes overnight, they cut it into the lengths they need to create the filigree glass piece. The colors and pattern inside a complex cane are determined by the choice and layout of the overlaid cane rods rolled onto the molten crystal. The filigree pattern is now determined by the way in which they lay out the complex cane rods. After fusing the laid out rods, they wrap them around a collar of hot crystal at the end of a blowpipe. While rolling the piece on a glass-blowing bench, they use a scissor-like tool called jacks to close off the end. They snip off the excess with shears. Then they roll the hot glass on a wet wood block to smooth and round the bubble. They blow in some air to produce the shape of a pear, stick a punty to the bottom of the pear, then use cold tweezers to shock the hot glass into breaking along the separation line, and transfer off the blowpipe. Now they take some hot crystal from the furnace and roll it in fine granulated colored glass. They reheat to melt the color into the crystal. Then attach a bit of glass to the top of the pear to form into a stem. They smooth the cut-off edge with a small torch. They take another bit of molten colored crystal to shape a leaf. This crimping tool imprints the veins. Every filigree piece these Canadian master glassmakers create is signed by way of a piece of cane bearing their initials. They fuse it to the piece in a discrete location. Now the finishing touches. Reheating, then some shape tweaking with tools and wet newspaper. With the artist's work done, it's time to enjoy the spectacular fruits of their labor. Flake foods for aquarium fish were invented in the middle of the last century. And what a difference this invention has made. Before they came along, pet fish were fed live food from rivers and streams, a food source that wasn't always accessible. The invention of flake and other dried foods made life in a fish tank a whole lot easier. Just a few sprinkles and dinner is served. It's not much like the live water fleas or bloodworms the fish would feed on in their natural environment, but it contains the nutrients and vitamins they need. These dried tidbits can be supersized to appeal to larger fish that prefer to chow down on something more substantial. Each formulation consists of up to 40 different ingredients. The main components are fish meal, wheat flour, soy and paprika oils, and they also add food colorant because fish are drawn to certain colors. They follow a precise recipe and measure the ingredients carefully. They blend the smaller components together first. They include lecithin, a blending and thickening agent also found in foods humans consume, and calcium for bone strength. The main ingredients, the fish meal, flours, and oils, are piped from silos into big tanks and mixed with hot water. They add the smaller premix and blend everything together to produce a thick slurry. They spray the slurry onto the surface of a series of rolling heated drums. As it flows over these drums, the slurry cooks and dries into a thin film that's like a paper sheet. As the sheet rolls off, a long rotating blade chops it up to produce big flakes. They're pretty chunky at this point and will need to be broken up into bite-sized versions. Next, they fall down a chute and into a plastic bag. A worker transfers them by the bagful to the next conveyor. The various colors represent the different formulations. The green are veggie flakes, while the red are protein-based. They all head into a spiraling device known as the tumbler. It spins to toss the flakes around. This mixes and breaks them into smaller flakes. After several minutes in the tumbler, the flakes fall onto a series of screens to grade them by size: small, medium, and large. They land in separate bins, now mixed and sorted by size. Meanwhile, the production of fish food sticks is underway. Machinery presses a food mash through the small holes of an extruder plate to create spaghetti-like strings. As the strings exit, rotating knives cut them into sticks. The sticks dry and solidify. A worker routinely examines them for size and form. The next worker wheels a hopper full of flakes above a chute and removes the trap door. The mix falls down one floor onto the packaging line. At the same time, a column of empty cans heads towards the flakes. The fish food flakes fall through special openings that funnel them into the cans. Machinery cuts out aluminum foil caps and slaps them on the tops of the containers. Hot circular irons then seal the caps to the cans. This conveyor belt is also a computerized scale, which keeps track of the amount of product in the cans. Then devices spin by to twist plastic lids onto the threaded rims of the cans. As the cans pass by on a carousel, applicators press glue-backed product labels onto them. And these fish food flakes are done. In its various formulations, dried fish food offers a range of feeding options. Some contain additives that enhance the growth and color of the fish. Others are geared to a fish's specific tastes, because even pet fish can be discriminating diners. A motorhome is a fully equipped house on wheels. The Class A types are shaped like a bus, the largest models more than 12 meters long and spacious enough to sleep up to 6 people. When parked, the exterior room walls slide outward, expanding the width by more than a meter. Motorhomes have driver and passenger seats at the front, and in the back, the essentials of a small house: kitchen, bedroom, living room, bathroom. The factory buys a ready-made, standard-length steel chassis from an automotive supplier, with motor and other components already installed. They then lengthen the chassis by cutting each side and welding on an extension piece. They also extend the pre-installed exhaust system and electrical wiring. Then they weld on steel plates to reinforce the splices in the chassis. Next, they lower the steel basement frame, which has compartments for the water supply, waste collection, and storage. Before installing the frame, they attach 3 pairs of sliding hydraulic cylinders, called rams. Each pair operates a slide-out room at the push of a button. After bolting the frame to the chassis, they spray each welded joint with an anti-rust coating. Then they test the rams to make sure they slide in and out properly. They lower the pre-assembled steel cab structure onto the basement frame and weld it to the chassis. The motorhome's front end is made of fiberglass, with the bumper and headlights built in. Workers connect the headlights to the electrical system, then attach the front end to the cab structure. They install the hood and make any necessary adjustments. Next, they load up the compartments in the basement structure, starting with the fresh water tank made of durable white plastic. Water runs from this tank through flexible plastic water lines to the sinks, shower, and toilets. Next, the drainage line for sewer waste. It runs to a plastic tank that's gray to differentiate it from the water tank. Now they run a line of heavy-duty adhesive along the steel grid of the basement structure and set down the motorhome's floor. The floor construction is like a sandwich. Aluminum on the bottom, plywood on top, with a high-density hard foam in the middle to muffle noise and absorb road vibration. After securing the glued floor with screws, they staple carpet underpadding onto the plywood. Except in the kitchen and bathroom areas, where they lay down vinyl or ceramic tile flooring and cut holes in it for heat registers and drains. They install carpet over the underpadding. The pieces are pre-cut to the motorhome's layout. Large pieces for the main areas, small ones for closets and the cab. Now workers hook up what they've built so far to a chain mechanism that tows down an assembly line. First, overhead lifts lower the motorhome's 3 slide-out rooms, dinette, living room, bedroom, onto their respective rams. Workers bolt the rooms to the rams, then test them. Next, workers install the bathroom cabinetry, plumbing, and wiring. Then the motorhome gets its 3 remaining walls. They're fiberglass on the outside, decorative paneling on the inside, with foam and an aluminum structural frame in between. The back wall has a luggage compartment accessible from the outside of the vehicle. Like the headlights on the front end, the vehicle's tail lights are integrated. The roof structure is the same as the walls. It has electrical wiring built in and cutouts for ceiling lights and air conditioning vents. The inner structural frames of the roof and walls interlock. A line of screws running the length of the roof secures the connection. A generous application of sealant, then on goes the roof cap with built-in clearance lights to finish off the front end. At this point, the outside of the motorhome is almost complete. However, there's still much interior work to come. Everything on the inside is designed to maximize living space and storage space. And even though the motorhome has just 1 bedroom, pull-out beds in other areas add additional sleep space. One of the last jobs remaining on the outside is to install the door. It fits perfectly because they constructed it using the piece they cut out of the sidewall to make the door opening. Next, some decorative detailing on the vehicle body, including an adhesive vinyl decal bearing the model name. On the inside, workers are busy applying the finishing touches. They hang cabinet doors, install under-cabinet lighting, and hook up the kitchen appliances. The stove is a special compact size manufactured specifically for recreational vehicles. Customers buying motor homes have a choice of window coverings. This order calls for double-duty roller shades. One setting filters daylight, the other blacks it out. The installer uses a gauge to adjust the blinds to the correct drawing tension. Then she installs decorative valances to hide the edges and pull cords. In the cab, workers bolt the base of the driver and passenger seats to the basement frame. Then they bolt a seatbelt receiver to each seat base. The seats, upholstered in high-end synthetic leather, attach into their respective bases. Workers install the dinette, which sits in one of the slide-out rooms. The bench seats have a storage area underneath, and the seats and table convert into an extra bed. At the rear of the motorhome is the bedroom, which is the second slide-out room. The bed has storage space underneath for blankets and pillows. Regulations designate certain seats safe to sit in while the vehicle is moving. Those seats are equipped with safety belts. The couch in the living room, the third slide-out room, has a few hidden features. An air mattress, which inflates and deflates at the push of a button for an extra bed, and a drawer underneath for storing pillows and blankets. The bathroom has a toilet, sink, shower stall, and lots of cabinet space. Back on the outside, workers install a rear-view camera on each sidewall. When the driver activates the right turn signal, the right side camera automatically turns on. The left turn signal, the left camera. The cameras transmit the image to a dashboard monitor. Every motorhome this factory produces undergoes extensive water infiltration testing. Hundreds of sprayers shoot several straight minutes of simulated heavy rainfall from all angles, including underneath, with the slide-out rooms both extended and retracted. Inspectors check everywhere, even inside cabinets. If they find any leaks, they seal them and run the water test again. And finally, one last mechanical verification of the slide-out rooms, now that they bear the additional weight of the furnishings. This expansion feature is the secret to the motorhome's spacious feel, as it increases the floor space width by nearly 1.5 meters. The slide-outs operate only while the motorhome is parked. With smart design and ingenious use of limited space, a motorhome lets you hit the road without leaving the comforts of home behind.